Hello there, and thank you for clicking on this video. This lesson is titled Radical Equations 1, and if you're wondering why it's Radical Equations 1, in this lesson, we're going to introduce radical equations, and we're going to keep the equations such that there's only one radical in them, and that they do not generate what are called extraneous solutions. If you are looking for more advanced radical equations, then you might want to check out Radical Equations 2, where we'll get into some more of the advanced ones. But if you're looking for an introduction to radical equations and a way to get your feet planted in the overall concepts, this is the video you want. Please like this video if you find it helpful. Super easy to do, to give it a thumbs up. Subscribe to the channel for more math content. Drop a comment to engage, and check out the practice set on this material. Always, always, always so important for you to get a chance to practice and review the concepts that are discussed in a lesson. Now, if you've been following the thread of Algebra 2 videos on this channel, okay, you know it's been a little bit since we've done solving an equation. We've been doing laws of exponents and rational exponents, simplifying radicals, that kind of thing. It's been a little bit since we've solved an equation. So what does it mean to solve an equation? Well, a solution could be defined as the value or values of the variable that make the equation true. Meaning, if you solve an equation and you get down to like x is equal to 2, if you plug the 2 back into the original equation, you would end up with a true statement. So you'd end up with something like 4 equals 4 or -2 equals -2, some kind of true statement. And that's what you're looking for when you're looking for the solutions. When we're solving a radical equation, our main strategy is to isolate the variable by undoing all that has been done to it. So it's a pretty straightforward strategy that we've got. We use that when we solve linear equations. So if you see adding, you're going to undo the adding with subtracting. If you see multiplying, you're going to do division. The only thing we add in here is if you see a square root, you will square it, okay, in order to undo the square rooting. If you see a cube root, then you will cube it in order to undo it. And so really it's just an issue of like, what order do I need to do these things in? Now, a little bit of a caution. For the practice set on this, you will need to remember the quadratic formula. So some of the problems in the practice set are going to dump out as quadratics that you would then need to solve, and you will need the quadratic formula. So if I can go find it, I will go ahead and link my video for the quadratic formula up in the upper right hand corner there, so you can check that out, and I'll try to link it in the description box as well if you realize, oh, I actually should go over that. So pretty much okay, so we're going to take a look at some examples, and forgive me if there's a little bit of break in that. If I cut off mid-sentence, I was on this slide and started to cough, paused the video, tried to resume recording, and just, yeah, the slides got all messed up. So I had to start at this slide again, and yeah, hopefully the editing is all right on it. So what we're going to do with this lesson is work through a series of example problems, because there's nothing really new in solving radical equations that you don't already know. Some concepts, when we go to solve the equations, we really have to lay down more groundwork, like when you're solving a logarithmic equation. The radical equations really build on things that you've already covered in your algebra journey. So looking at this equation here, we're going to like focus on the x there, and we want to notice what's being done to the x. Well, I am adding 5 to the x. So you start with your x, you add 5 to it, and so I know that somewhere in my solution I'll be subtracting 5. And then we're square rooting it, and you want to notice where the square root goes. Okay, the square root is covering the x and the plus 5, and so we've got the x plus 5 and then the square root. So you really want to pay attention to the order of operations there. That 5 is trapped under the square root, which means you can't just subtract 5 at the beginning, because it's like in radical jail, as we might call. So what we need to do is we need to look at the last thing that we did, which was the square rooting, and we need to undo that. Basically, we need to bust this thing out of jail. So I will go ahead and we have our x plus 5. Our x plus 5 is currently in jail. And the way we bust it out is by squaring it. Okay, if I square the square root, then I undo it. And it's really important to note that you're not squaring the x and the 5. You're squaring the square root. So this squaring is not going to generate an x squared. It's not going to generate a 25. All the squaring is going to do is get rid of the square root for us. Now, golden rule of algebra, whatever you do to one side, you must do to the other side. Therefore, if I square the left, I must also square the right. On the left side, the square root now is gone. Okay, and so what we're doing there, so we got the square root. We are operating the square root away to basically bust it out of jail. And now we're left with the x plus 5. And then on the right-hand side, I have 49. And now I am free to subtract the 5. So we have x is equal to 44, and we're done. Now, if you wanted to check it, okay, so this would be our check. We would take that 44, plug it in. 44 plus 5 is 49, and the square root of 49 is 7. And of course, 7 equals 7 is a true statement. Therefore, I know that 44 is the solution. It is the value of the variable that makes that equation true. Okay, that's a pretty basic radical equation. It's probably about as basic as you can get, where you just undo the radical by, in this case, squaring it, and then you're left with a linear equation to solve. And in this case, it was a one-step linear equation. Now, this one is a little bit more complicated. We have more going on. And what we need to remember to do here is follow order of operations, or I guess we're going to reverse the order of operations. So if I figure out where my x is, okay, and then think about what is being done to that x. Okay, what are we doing to the x? So I'm going to change my tool here. Okay, so I'm going to do a little bit of what we might call thinking. Okay, we're going to do some thinking up here. So the first thing that's happening to the x is we're multiplying it by 2. Okay, so times 2. Then we are subtracting a 1. Then we are square rooting it. Then we are multiplying by 2 again. And then we are adding 3. Okay, so kind of follow this. So here's the x. If you were to plug in a number for the x, you think like, okay, what would I do first? Well, I would have to do 2 times whatever the number was. That's multiplying by 2. Then I would subtract the 1 because the 1 is hanging out under the square root. Then we would square root it. Then whatever that number is, we would multiply it by 2, and then we would be adding the 3. And the reason it's adding 3 is because the 3 is positive. It's that positive, not that one, okay, for why we're adding the 3. So therefore, if I want to isolate the x, I have to undo those things in the reverse order. So I'm going to start this solution by subtracting 3. And that process is really a process that we want to become automatic. If I were to look at this on my own, I wouldn't even really think intentionally about what I needed to do first. And that is grounded in knowing those order of operations really, really well in the first place. So subtracting the 3 from both sides, 3 minus 3 is 0, causing that to cancel on that side. And we are left with 2 times the square root of 2x minus 1. And then on the right, 11 minus 3 is 8. Next thing I would need to do is undo the timesing by 2. That would be this 2 right here. This is multiplication. And so we would do that by dividing. And of course, whatever I do to one side, I must do to the other. These 2's divide out to a 1. 2 divided by 2 is 1. And that will leave me with the square root of 2x minus 1 is equal to 4. Going this way. Next thing that we would undo is the square root. And I'm just going to change up the color on that. So the way I undo the square root is by squaring. And that leaves me with, undo the square root, the 2x minus 1. And of course, remember again that squaring is how we're dealing with the square root. It is not applying to the stuff under the square root. We're basically busting that out of jail. and 4 squared is 16. And now we've got a two-step linear equation. So the next thing that was done was the -1. So we would undo that by adding 1. So we add 1 to both sides, getting 2x is equal to 17. And then the very last thing is the division by 2 to undo that original multiplication by 2. And so I would actually leave this as 17 over 2, but you might say 8.5. Okay, and what you might want to do is just go back and rewind the video. It's only about 4 minutes to explain all of that and work it out. And this thinking part is the critical part here, is you want to look at the x, look at what was done to the x, and then undo that in the reverse order. It's like putting on your shoes and your socks. You put your socks on before you put your shoes on. Therefore, when you undo it, you take your shoes off before you take your socks off. Okay, that's how it goes. So if I multiplied by 2, where's my mouse? I've lost my cursor. I really did lose my cursor. Oh, there it is. It's back. So if I multiplied by 2 before I subtracted 1, then when I go to undo it, I undo the subtraction before I undo the multiplication. All right. Third example, this one just gets into a radical that is not a square root. Now, the vast majority of radical equations that you would ever need to solve will be square roots. They are hands down the most common radical that you would see, but they are not the only radical you could see. So we'll take a peek at this one. This is a cube root. So the way that we would undo a cube root is by cubing it. And of course, we would cube both sides. So if I cube a cube root, I get what's inside. So I'm going to get the x minus 1. 5 to the third power is 125. And now we're left with a one-step linear equation there. And we get x is equal to 126. So same principles. I love that about math. It's very consistent. So whatever works for square roots is also going to work for cube roots. All right. And last one. So this one gets dicier, and this one isn't going to be too awful. This one actually comes out pretty nice. But this is where it can come out messy. And I mentioned at the beginning of the video, there's a couple problems in the practice set that you will want the quadratic formula for, because when you do this, you can dump out with a quadratic. So on the left-hand side, I can see that I have the square root of 4x plus 1, and I know I'm going to undo that by squaring it. So when you go to square it, it's important to keep this in mind. You are squaring the entire side. So you put this like parentheses around the whole thing, and you're squaring the whole thing. When you square the right-hand side, you must do the same thing. You cannot square one thing in its entirety and square another thing in fragments. It's not actually doing the same thing. And that gets into order of operations. Again, is the why on that. That basically, if you think of, okay, I am squaring this entire side, I must square the entire side. And that is not the same thing. Okay, so 2x plus 1 all squared is not the same thing as 2x squared plus 1 squared. So that squaring does not distribute, and it again comes down to order of operations. The order of operations here says you're going to add them and then square the result. This one would be squaring it and then doing the adding. So doing the changing up the order of operations changes everything. So you must, you cannot distribute some kind of squaring there. Now the left-hand side is pretty straightforward. That is what we think it is. That's 4x plus 1. But on the right-hand side, it might be beneficial to remember that to square something means to multiply it by itself. And you can do this part by foiling. If you've followed all of my videos, you know that I would use the area model to multiply this, which would look something like this. Okay, 2x plus 1, 2x plus 1. So this would give me 4x squared plus 2x plus 2x plus 1. And then I would add those all up. And here is where we have a quadratic dumping out. And now your quadratic solving skills have to come into play. Now, to solve a quadratic, we've got several different strategies we can pick from, but the main strategies are the quadratic formula and factoring. Either of those strategies require that you get a 0 on one side. So to get that 0, I am going to subtract 4x from both sides. And I'm going to go ahead and subtract 1 from both sides. On the left, 4x minus 4x is 0, 1 minus 1 is 0. So that gives me the 0 that I need. And then I've got 4x squared, and then something weird happens right here. 4x minus 4x is 0, and 1 minus 1 is 1. And so this whole chunk of stuff cancels out. That does not normally happen. So normally you would be left with something there that you would then either factor or throw into the quadratic formula. But in this case, you end up with a 0. And then we can proceed from here. So divide both sides by 4. 0 divided by 4 is 0. And then we would take the square root of both sides, and we end up with 0 is equal to x, okay, or x is equal to 0. Now, we might want to do a check. You end up with a solution like that. You're like, I'm not sure about that. So let's go ahead and just see what that check is and make sure it works. So under the square root here, 4 times 0 is 0, leaving me with the square root of 1. 2 times 0 is equal to 1, and the square root of 1 is 1. So I get 1 equals 1, which is true. And so I do know that this does indeed check. But again, this would be where you would want to engage either factoring or the quadratic formula. All right, so that's pretty much it. This lesson was not heavy on explanations and definitions and all kinds of like cautions. I mean, I did give you some cautions, but it's pretty much just stuff you already know. You already know that like squaring and square rooting undo each other. You already know how to solve a linear equation. You already know how to solve a quadratic equation. The only new thing that is introduced here is the process of undoing the radical and thinking about where in your solution you would take that new step, and that goes back to your order of operations. So that pretty much wraps it up. Please give this video a quick thumbs up if you found it helpful. Subscribe to the channel for more math content. Check out the practice set on this material, including that review of the quadratic formula if you realize that you need it, and drop a comment or question below to engage. I hope to see you in a future lesson.